Shivam Rajput back again with the new video on a video series of CSIR and AJF Sciences. Today I am back with a very important topic, that is stable oxygen isotopes. Now this particular topic is heavily requested by you guys, Mansi, Raza, Tanya and all. So here in this video I will be covering this particular proxy which is from paleoclimatic section of CSIR, and at the end of this video I will cover one numerical from CSIR. And if you see previous year question, there are 10 plus questions direct from this particular topic, and even this time they asked one match the following from paleoclimatology, and that also having 18 to the 16 ratio. So without wasting time, let's start the video first. We'll cover everything, but we'll start with the very basic, that is isotope. What a isotope means, because here you can see stable oxygen isotope. So what is this isotope means? Isotope is nothing but when a atom is having same atomic number but different atomic mass. What is atomic number? It is number of proton. What is the atomic mass? Number of proton plus neutron is called atomic mass. So in case of oxygen, we have three different stable isotopes, that is O16, O17 and O18. O16 is 99.7%, O17 is 0.03%, and O18 is 0.20%. Okay, so if you see in these three cases, the number of proton will be the same, 888 for 16, 17 and 18, but the number of neutron will increase by 1 in every case. Okay, in 17 it is 8 proton and 9 neutron. In case of 18 it is 8 proton and 10 neutrons. Okay, now for this here also you can notice that it is a stable isotope. What is the stable means? So stable means it is neither producing any alpha beta gamma rays, nor it is turning to some other element with time. Okay, there are unstable elements which are generally radioactive and can be radiogenic also. So what is the radioactive element? When unstable element, to make it stable, start emitting alpha beta and gamma rays and turn into some other daughter element, that is called radioactivity. This process is called radioactivity process, and the element which is produced during this process is called radiogenic process. So the result of radioactive process will produce radiogenic elements. Are you getting my point? So we'll see how climate controls the isotope ratio. Now if you see, we have water in the atmosphere, in the clouds, in the uh, ice sheets, in the oceans, right? Now this water is having a particular chemistry, that is H2O, yani two molecules of hydrogen and one molecule of oxygen. Now this hydrogen can be anything. It can be prosium, deuterium, tritium, and if you see oxygen also, it can be either 16, 17 and 18. Here we are looking for O16 and 18, 18 to the 16 ratio and deuterium to the prosium ratio. So we'll see according to that. Okay, now if you see during evaporation what happens? Simply the bond between different water molecules break, and it changes the phase from the liquid to the gas, right? So during evaporation, it is easy to break a water molecule having O16 in it than O18, because O18 is the heavier one, so more energy is required to break that bond. But for O16, less energy is required. So during evaporation, H2O16 will evaporate first. Okay. While during precipitation, during condensation, O18 will condense first. Okay, it's a just opposite. So whatever is evaporated from the ocean will rises to the some altitude, and over there now condensation will occur. Now suppose from ocean 100 out of 100, say 90 molecules of O16 is evaporated and 10 molecules of O18 is there. Okay, now during condensation these 10 molecules will condense first. Okay, so if you see like this, in the ocean what will happen? More and more 18 will be increased, more and more 18 will be there, no, because 16 is getting evaporated. While if you see the clouds, more and more 16 will be there because 18 is precipitating out. Are you getting my point? Now see this. Here we have two conditions. One is glacial condition, one is interglacial condition. So during glacial condition, what happened? The total radiation reaching the earth's surface will decrease, right? And we know that less amount of energy is required to break O16 bonds than O18. Okay, So more and more O16 will come out of the ocean, right? So that means the amount of O16 in the ocean will decrease. Now, if you see this O16 over here, if you decrease O16, the relative proportion of O18 will increase in the ocean. That means, right? Because you are removing O16 from the ocean. So now the relative proportion, O18 will not increase. Its proportion will increase. So the proportion of O18 will increase. That simply means 18 to the 16 ratio is now positive because numerator is bigger and denominator is smaller. So it will become positive. So remember, during glacial condition in the ocean, 18 to the 16 ratio is positive, yani increasing. Okay, now it is evaporating. Okay, so here it will condense, and this condensation will with height also the cloud will move to some other latitudes, to the higher latitudes where it finally precipitates out. If you see, most of the O18 will condense and precipitate out in the lower tropical regions only. But as this cloud will move towards the higher latitudes, it will be enriched with O16. Why it will be enriched with O16? Because I already told you the heavier isotope will condense first. So that means more and more O16 will be dumped into the ice sheets of Antarctica and Greenland. Right. Now here we have more O16. Yani denominator is bigger than numerator. So that means it will be negative. Are you getting my point? फिर से देखो इन हिंदी, यहां से O16 निकला, ज़्यादा इवेपोरेट होकर O16 पहले निकलेगा, राइट? ये O16 एटमॉस्फेयर में जा रहा है, वहां क्या हो रहा है? कंडेंसेशन स्टार्ट हो गया. नाउ जब कंडेंसेशन स्टार्ट होगा तो पहले कौन कंडेंस करेगा? O18. ओके, 16 के रिस्पेक्ट में O18 पहले कंडेंस करेगा. तो अगर कंडेंस कर रहा है तो प्रेसिपिटेट आउट भी पहले होगा. सो लोअर रीजन्स में इन द ओशंस ओनली सारा O18 प्रेसिपिटेट आउट हो गया. अब क्लाउड किस में इनरिच है? O16 में. ये क्लाउड किधर की ओर जा रहा है? टुवर्ड्स द हायर लैटिट्यूड्स, एंड ओवर देयर फाइनली प्रेसिपिटेशन तो होना ही है. सो फाइनली जो प्रेसिपिटेशन हो रहा है दैट इज हैविंग मोर O16 इन इट. सो इसका रिजल्ट क्या हो रहा है कि 18 to the 16 रेशियो निगेटिव हो जा रहा है, बिकॉज नाउ 16 इज मोर. सो यू आर डंपिंग मोर एंड मोर O16 टू द ice sheets, right? So that's why it is negative. Now this is the glacial condition. So during glacial condition you can see literally there is an advancement in the ice sheets, and here we have more O18 in the ocean. Now interglaciation period देखते हैं. So what happens in interglaciation period? The ice will melt. When ice will melt, अब देखो इस ice में which is more? O16 is more. That's why 18 to the 16 ratio is negative. तो सारा O16 जो इधर dump हुआ था during glacial period will now melt and goes back to the ocean. It goes back to the ocean. So what will happen? Now 18 to the 16 ratio will affected by this. Are you getting my point? Because it is returning back, no? The O16 which is trapped over here is again going back to the ocean. Now see this very carefully. Oxygen has two major isotopes, 18 which is considered to be heavy, O16 which is considered to be light. Both of these isotopes are stable, yani non-radiogenic. So basically with time the ratio will be constant. It won't change to the daughter element. Okay. Now because O16 is lighter, it is lighter, so it is easy to evaporate from the seawater, from the ocean water, and thus concentrated in the water that is eventually falls on the continent as a rain or snow. So 16 उससे निकल रहा है from the ocean, it is going into the clouds, and that then cloud is precipitating out on the continents in the form of snow somewhere in the high altitudes and high latitudes, and there is more O16 in it. But because of this process O18 is concentrating in the ocean. Now during constant climatic condition, so just remember There is no glacial period, no interglacial. Right now we are in the period of interglaciation. It is a global warming period, so it's not a constant climatic condition. So just think of it, there is a constant climatic condition. At this point of time, the O16 lost to the evaporation returns to the ocean by rain and stream. So the 18 to the 16 ratio will be the constant in normal climatic condition. But what happened during the glaciation? During glaciation, the total energy reaching to the surface is less than interglaciation. So it is easy to evaporate O16 than O18, and right now we have sufficient amount of energy to evaporate O16 from the ocean. So some of the O16 which tied up in the glacial ice doesn't return to the ocean because it is already a glaciation period, it's a cooling period. So there will be glacial expansion, right? It won't come to the ocean, वो तो expand करेगा ना, melt नहीं करेगा, right? Thus during glaciation 18 to the 16 ratio in the sea water will increase. क्यों increase कर रहा है? एक तो 16 is not coming back to the ocean. Second, here whatever is evaporation takes place during glaciation period, it is mainly O16. So 18 का concentration is rising. But during interglaciation period, what will happen? Whatever ice is tied up on the high latitude in the form of ice rises, ice sheets that start melting, और वो जब melt करेगा, the O16 which is tied in the glaciers will return to the ocean. That caused decrease in 18 to the 16 ratio in seawater. Now how can they ask this question? They will ask like during glaciation period 18 to the 16 ratio will increase, decrease, unchanged, doesn't depend ऐसे. So always remember glaciation में 18 to the 16 ratio will increase. During interglaciation in the sea water 18 to the 16 ratio will decrease. They can also ask what about the ice. So during glaciation period always remember 18 to the 16 ratio will decrease in the ice. Just opposite of it. How? Let's see. यहाँ देख रहे हो 18 to the 16 ratio is negative during glaciation period. At the same time here it is positive. So always remember in case of glaciers it will be opposite of oceans. Okay, because more and more 16 is dumped over here. So 18 to the 16 ratio already negative ही होगा. Are you getting my point? So these two statements you have to remember. Also based on this you just reverse of this glaciation period में in the ice cores, in the glaciers, the amount of 18 to the 16 ratio will decrease in glaciation. Remember, and here it is increase. ठीक है, glaciers में, not in the sea water. Now let's see the relation of this fractionation of isotopes with altitude and with latitude. So with increasing distance from the water source or with increasing altitude, precipitation becomes more depleted in O18. Okay, यानी क्या कर रहा है? Basically, as you move away from the source area of evaporation, more and more O18 will be depleted in the clouds. So the cloud which is reaching by far distance from the source will having more and more O16 in it. 18 will precipitate initially. So O जो 18 है वो पहले ही precipitate out हो जाएगा. By the time वो दूर जा रहा है away from the source area, उसमें अब ज़्यादा से ज़्यादा क्या है? O16, and that's why O16 is there more in the glaciers, ना कि in the lower regions, in lower latitude. वैसे for altitude, if you see different heights, clouds at different heights, the one cloud which is at the lower altitude is having more O18 than the cloud which is at higher altitude. Are you getting my point? So यहाँ देख सकते हो जैसे जैसे it is moving away, the concentration is decreasing. -3 parts per thousand per mil जिसको बोलते हैं O18 यहाँ है, और यहाँ it is -11 because the distance is increasing and it is minus. Okay, so are you getting my point? Now how this ratio is used to paleoclimatic reconstruction, for paleoclimatic reconstruction. So now think of it. We have different organisms in the oceans. It can be coral, it can be sponges, foraminifera, diatom. What is common in between them? These are either made up of calcium carbonate, it is either made up of silica oxide. So what is common? Oxygen is common, right? So during the formation of their skeleton is made up of what? Calcium carbonate. Okay. So during the formation of their skeleton, some oxygen is tied up in the chemistry of CaCO3. Some oxygen is tied up now because whatever they are making, they are basically taking out of from the oceans only. So how it forms? Calcium ion is there in the ocean by weathering erosion of rocks, and carbonate ions again it is coming from the oceans, from through the streams, different streams. Now these ions, Ca2 plus ions or CO3 2 minus ion is there in the ocean. Now organisms use these ions to make their cells, and that help us for further living. Okay, जीने के लिए that is very important. So during formation of this CaCO3, they took some oxygen from the oceans. And if we get the ratio of oxygen in their cells, we indirectly can say that what is the ratio of these isotopes at that particular point of time. So if 18 to the 16 ratio, if 18 to the 16 ratio is like higher, then we can say that there is a glaciation period, right? If 18 to the 16 ratio in their cell is less, then we can say that there is an interglaciation period at that point of time when they make their cells, right? So here we have some animals like sponges, corals. Now you have to know this: corals is having calcium carbonate, but this mineral calcium carbonate is a rock, right? It's a sedimentary rock, but the mineral which is there inside calcium carbonate is not calcite. Calcite is CaCO3, but at the same time there is another mineral called aragonite that is also CaCO3 that is having orthorhombic crystal structure. So it is on the surface, and aragonite is more stable in the surface water. If you put aragonite down inside the water, it will simply dissolve. Okay, so corals are made up of aragonite, remember. Here we have foraminifera and then mollusk. These are basically having calcite, CaCO3, and using these cells, we can reconstruct the past. We can say something about the temperature at that point of time, whether it is glaciation, interglaciation, like that. We can use this coccolithophores. This is again having calcareous cell. So based on these data, we can reconstruct the past like this. So here we can see that the past 65 million years in time, like देख सकते हो यहाँ, there is a cooling and warming trend. Based on this data, we can literally see there is a events of cooling and then warming, then cooling and then warming, and somewhere here the present time, if you see this plot, it is little bit shaky. It is going up and down. But when you exaggerate it, when you expand it, you will get something like this. And just after this 1700 or somewhere after the post-industrial age, you can literally see there is a warming trend. So these all datas are based on 18 to the 16 ratio, which can be taken either from ocean water or cells of organism, from the ice cores, can be anything. Okay, this is Northern Atlantic water temperature. So we'll see, literally using this particular proxy, we can reconstruct the past. And not only this, we can use some supporting data also. So suppose we are using foraminiferas, their cells for oxygen isotopes. We also can look for their morphology. Okay, so some foraminifera is right coil foraminifera, some are left coil. So if it is a right coil, it must be in the warm ocean water. Okay, if it is a left coil, then it must be found in the cold ocean waters. So it can be used for verify our 18 to the 16 ratio with their morphology also. These are basically isotopic signatures that can be very useful for paleoclimatic registration. Again, we can use these corals, mollusks. So these are again having calcareous fossils, and they are calcareous fossils, and whatever is there in their cells, 18 to the 16 ratio, that can be used. We can use also growth lines. So here you can literally see there are different growth lines. It's like a tree rings also. It is literally like that. So based on these growth lines, we can uh, we can estimate seasonal temperature variation. So each growth line indicates one season. Okay, so you can get 18 to the 16 ratio seasonally. How seasonally it varies. So in the year also, if you see, there is a summer time, there is a winter time. In winter time, the concentration of 18 to the 16 will be different than the summer, right? So using this growth line, we can estimate up to seasons. तुम seasons तक जान सकते हो. Forget about the million years time gap. Just a season, just a 6 months. You can reconstruction using this. And there are something called paleosols. So paleosols are like nodules only. So we have something called manganese nodules. That is again a paleosol. Okay, so here we use the paleosol, which is made up of calcium carbonate. So when this calcium carbonate dissolve, it sips into some cracks and crevasses in the ocean floor, and there it basically precipitates out, the water precipitates out, and calcium carbonate solidifies over there. That calcium carbonate can be used to reconstruct the past. We can use appetites. You have from the teeth of from the tooths of different organisms. So here we have ancient teeth of some shark and conodonts. उनके teeth में there is this element called there is this compound called apatite. Apatite में ये basically phosphate होता है, calcium phosphate. So even our हमारा जो दांत है, this teeth, in the enamel of this teeth we have apatite, और उसमें भी will have phosphate में क्या, the oxygen is there, no? So wherever it oxygen अगर रहेगा, whether it is in calcium carbonate, whether this oxygen is in the water molecule, whether this oxygen in the silica of what, diatoms, radiolaria, इसमें भी silica है ना, SiO2. So if oxygen is there, we can use that to reconstruct the past. Like यहाँ देख सकते हो, here we have this diatom, oxygen isotope from the diatom can be used. This is a microalgae only. So and this is something I used to work. So this is ice core, and we reconstruct the paleo temperature from the water molecule which is there in the ice core. So ice core is made up of what? It is nothing but a frozen water only, no? So we take different sections at each 5 centimeter resolution. We'll take one section from that 5 centimeter resolution, we melt it, and that melt will goes into the instrument called TWIA, a triple water isotope analyzer, and there we analyze deuterium, O18 to the 16 ratio, all those things. And in this way we come to know how temporally with the time how the 18 to the 16 ratio varies. And if we use multiple ice cores, we can go up to spatial variations, and like this we can go up to 800,000 year backs. So like 8 lakh साल पीछे तक जा सकते हैं based on this ice core from Antarctica. So it is very very interesting kind of thing. And then there are some ambers में भी जाता है air bubble trap, and that air bubble trap can be used because उस air bubble trap में भी we have oxygen, right? Even in a case of ice cores also, if you see, there are bubbles inside it, and that bubble will help you to understand the paleo atmosphere कि at the time of snowfall, जब ये ice core बन रहा होगा, कैसे ice core form होता है? Basically from snowfall हुआ, right? That snow turns into fern, with the fern after few years it will turn to the ice, right? और हम फिर उस ice core को लेकर आ रहे हैं. तो इस fern में, इस ice में you will have some air bubbles, and that air bubbles is having some gases which is trapped inside it. So you can literally see methane, carbon dioxide. So you can reconstruct at that point of time कौन से greenhouse gases थे. Okay, and you will literally see whenever the ratios predicts that it is having interglaciation period, उस समय there are more greenhouse gases in the air bubbles. Simple है, simple concept. Okay, So as you guys know that right now we have the biggest offer ever और finally September में एग्जाम है. अगर अभी कोर्स नहीं लिया तो फिर फायदा नहीं. एंड वी आर बेस्ट इन दिस पर्टिकुलर फील्ड. जब CSIR की बात आती है तो दिल पे हाथ रख के बोलते हैं कि वी आर द बेस्ट, क्योंकि इतनी सारी चीज़ें कोई नहीं दे सकता. वी आर द वन, वी आर द लीडर. ओके, सो लेट्स टॉक अबाउट वन न्यूमेरिकल फ्रॉम CSIR एंड खरीद लो यार अब तो. सो basically the numerical is based on VSMOW. It stands for Vienna Standard Mean Ocean Water. So basically they ask for delta 18O. Okay, in that particular numerical, let me show you the numerical first. So here question is something like this: given 18 to the 16 ratio, VSMOW is this much. The 18 to the 16 ratio of a sample whose 18 delta 18O is 25 parts per thousand, that is per mil. Okay, actually it is a per mil, it's a unit of delta 18O. Okay, is so basically पूछ रहा है कि you have to tell delta 18O sample जिसका 18 to the 16 ratio की value is प्लस 25 पर मिल. ओके, उसका क्या होगा निकालना है आपको. ओके, 18 टू द 16 फॉर अ सैम्पल यू हैव टू फाइंड. सो देखो यहाँ क्या है, हियर वी हैव स्टैंडर्ड वैल्यूज एंड यू हैव द सैम्पल वैल्यू. ओके, तो इस क्वेश्चन में तुमको ये निकालना है. ये गिवन है, स्टैंडर्ड वैल्यूज गिवन है, सैम्पल का निकालना है. सिंपल है, समझ में आ रहा है कि नहीं. तुमको ये दे दिया और स्टैंडर्ड दे दिया, तुमको सैंपल में निकालना है. वी हैव स्टैंडर्ड वैल्यूज फॉर 18 टू द 16 रेशियो. ओके, अब हमारा सपोज आई स्कोर है. आई स्कोर एक सैंपल है, उस सैंपल में 18 टू द 16 रेशियो की वैल्यू क्या है, दैट यू हैव टू फाइंड. ओके, सो सॉल्यूशन लेट्स सी. दिस इज द फॉर्मूला, जस्ट अनदर वर्जन ऑफ दिस फॉर्मूला. हियर यू कैन लिटरली सी, इसको 1 हम कर दिए into 1000. why 1000 is written over here? So 1000 is basically for per mil. Per mil के लिए we used to write 1000. R is the ratio of heavy isotope to the lighter one. R sample and what is R standard? It is the stable isotope ratio in the sample and the standard respectively. The result expressed in per mil. So that's why parts per thousand वैसे हम लोग लिखते हैं. So we'll simply put the values. So delta sample क्या लिखा हुआ है, प्लस 25. it is already given. This we don't know, 18 to the 16 ratio, that this we have to find. And given 18 to the 16 ratio according to standard value, that is this much. We'll put over here. When we solve this, we'll get the value that is 2055.3 into 10 to the power minus 6. ये ढक रहा है. So basically value आएगा 2055.3 into 10 to the power minus 6 when you solve this. Easy है, बहुत ही आसान है. तुमको स्टैंडर्ड की वैल्यू दे देंगे, सैंपल की वैल्यू पूछेंगे, डेल्टा 18O की वैल्यू दे दी है. ओके, जस्ट पुट द फॉर्मूला एंड सॉल्व द. ओके, दैट्स इट फॉर द टुडे. होप यू लाइक द वीडियो. चलो फिर परचेज द कोर्स and see you. If you have any doubt, please let me know. I'll be there to help.